Hello and welcome to Science Club Daily. I'm Ross Bolt and I'm being joined today by Tina. Hello.
Hey, so what do you have to share with us today?
So today I actually have an interesting one, and it kind of struck close to home because I was in Asia last year for a holiday, and I actually was going to say subjected to, but I think I'm one of the few people who actually enjoyed this experience. So have you heard of the durian fruit?
Being from Malaysia, I am very, very familiar with durian fruit.
And there's a related one called the jackfruit, right?
Yes.
So the durian fruit has a reputation for being extremely smelly.
Just to put it into context, in Malaysia, we have signboards in certain hotels and areas just telling people to not bring it in.
Same in Bangkok, like it's banned. Like the fruit is just banned, right?
It's that bad, trust me.
So I actually got to try some though. So I went to somewhere where you can get fruit and tried it, and actually I didn't find the smell that bad personally. And I think this is something I've heard where like some people, maybe just genetically, you know how some people just really hate like cilantro.
Oh yeah,
spacing on the proper word for it.
It is cilantro.
Coriander, cilantro, right?
Yeah.
Some people absolutely hate that. They think it tastes like soap. I love it personally. And so the durian fruit to me didn't smell that bad, and actually it tastes quite nice. Like it's quite a sweet taste, and it's got a very interesting like creamy texture. Which is kind of weird.
Yeah.
But that has nothing to do really with what I'm talking about today. But I just wanted to contextualize this. Yeah. So researchers from the University of Sydney have essentially found a way to use jackfruit and durian fruit and use the waste part. So there's the actual fruit part, and then there's that sort of fibrous part in the middle.
Yes.
That isn't really useful for anything. In fact, it gets thrown away. Now, what they managed to do with this, which I find really interesting, is they basically put it in an autoclave, which is quite important because autoclaves are quite moist, right? They're filled with steam, and that creates this tremendous pressure, and it heats the waste to about 180 degrees. And then what they would do is they would basically like put it in an oven and dry it out. And the fiber basically, they would do all these washing steps, and over time, all of the sort of non-essential bits, they would get washed away. And all that would be left is this kind of very carbon-rich like matrix. Because obviously a lot of fruit, they're made of a lot of mostly carbon, right? So sugars, fibers, all proteins are basically mostly carbon with a bit of hydrogen. So they would bond the water and the carbon, and then they would basically like flush nitrogen through it. To kind of soak it in this like nitrogen. And the reason they did this is they wanted to make something called supercapacitors.
So does that mean it has a capacity to charge electrical energy?
Exactly. So that's the really cool thing, right? So it turns out at the moment, supercapacitors are made from pretty expensive materials like graphene and sort of artificially created carbon-based structures. And the interesting thing is that these durian and jackfruit, the bit that they use, which is waste, essentially, like they call it a zero-cost substance. Because basically it stinks and people don't even want this thing. They don't need to use any special chemicals or anything like that. It's just basically a completely sort of heat treatment-based process. And because of the structures has these like pores, so they have these like hexagonal shaped pores, and these pores are all through the fiber. And what that means is that the fibers have a massive surface area. And that's really good for storing charge. And the cool thing is that you can charge these extremely quickly, and then they can use to be charged. You can basically discharge things into like mobile phones and like electronics to charge those equally as quickly. And the cool thing is that compared to these more like industrial style supercapacitors, apparently these aerogels made from durian fruit, they actually have a much better charge-recharge cycle.
Oh, that's brilliant. Because, I mean, the number one issues we have with batteries is that a year after usage, its capacity to retain the charge just drops dramatically.
Exactly.
And they're not cheap either as well.
Oh, absolutely
so the turnover is just
That's
ridiculous.
the thing. These substances, graphene, they're incredibly expensive. The materials aren't, I mean, look, it's made of carbon, but it's not actually that easy just to sort of get carbon into those processes, right?
But remember, carbon is used to make lead, like lead in pencils, and at the same time, it also makes diamonds. So it's a process around formulating that carbon. That's where the cost gets pretty expensive.
Exactly.
Right?
So basically, like one of the most important parts of this process is that the sort of they call it the hydrothermal treatment. That's
the autoclaving and
you know, so that the extreme heat and the vapor. What that does is it cleaves off what's called the functional groups of the amino acids.
Right.
So most amino acids would have these extra bits that are actually important for the function, right?
For the protein
Each
itself.
amino acid has its own little groups, but this strips those and then creates these kind of pure carbon hydrogen structures. And I just think it's amazing that, you know, that you can do this kind of stuff with something as basically useless as like durian fruit waste.
Yeah, and this all fits into the theme of making the most of what products we use, really, or the application of zero waste, really.
Exactly.
Because there is literally no function for the shell of a fruit right now.
No, absolutely not. Yeah. Like there is really no reason whatsoever to keep it. People don't want it. It kind of stinks. And yeah, they just kind of, they managed to get really good performance. Like these weren't just like, you know, like sometimes this research gets done and it's like, oh yeah, we proved we could do it. Isn't that cool?
So a famous example would be the potato battery. Just because we could use it doesn't mean it really has any real application. Like I wouldn't charge my Samsung with a potato battery now, would I?
Yeah. But the thing is with this is that not only is the charge, you know, like large, but the actual charge and release of energy is really quite smooth compared to a lot of processors, which will be really important when you're, say, plugging your phone into it. You don't want a massive spike of energy because that could hurt the phone. But because it's like a really smooth discharge, this could actually genuinely get turned into something useful, which I think is pretty interesting.
Definitely is.